I'm Dr. Riddhi Kadrekar from Amity School of Applied Sciences, Amity University, right? So today we have a talk on career options in applied physics, basically focused on nanosciences. And we have our esteemed speaker, Dr. Arif Sheikh. Let me just, before beginning, let me just introduce to you Dr. Arif Sheikh. He is a master's in physics from, he has done his master's in physics from Shivaji University, and he has done his PhD again in physics with a specialization in material science from Savitribai Phule, Pune University, right? He was a research associate, which was awarded by CSIR, Government of India, at NCL, National Chemical Laboratory, Pune. Then he also completed his postdoc at King Abdullah University of Science and Technology, Saudi Arabia. He worked as an Inspire faculty in the School of Nanoscience and Nanotechnology, Shivaji University, Kolhapur. And he's currently working at Amity University as a CRB research scientist, right? He has published about more than 50 research publications in international journals with 3,900 citation and an H index of 27. His publications are in varied journals with such as Nature Communication, Advanced Energy Materials, Advanced Materials, etc. Right? So he has a funding worth of 1.4 crore rupees, and he has supervised till now about around 30 master's theses. So he is interested in the fields of solar cells, gas sensors, photocatalysis, basically the field in which most of our physics students prefer working, right? So today he is going to guide us all on the career options that are present in the field of, specifically for applied physics students or physics students in the field of nanosciences and nanotechnology. So I request Dr. Arif Sheikh to please continue with his talk. Arif sir?
Yes. Just a minute.
Yes, sir.
Thank you, Vidya madam, Dr. Vidya madam. So let me share my screen, right? Yeah, can you share my? Can you see my screen?
Wait for a while, sir. It's still going on. Process. As soon as we can see it, yeah, the screen is visible, sir. Sir, the screen is visible.
Right. So let me put it to full screen. Is it fine?
Yes, sir, it is perfect. It's visible.
You can see my full screen version, right?
Yes, sir. Yes, sir.
Yes. So thank you very much, Dr. Riddhi madam, for your brief introduction. And herewith today I am going to highlight some of the important points regarding the title Career Opportunities in Applied Physics and Nanosciences. So basically, this is going to help for those students who are looking for a future career in the subject like applied physics and nanoscience, nanotechnology. So hope this information is going to help them. So with this, I would like to welcome all the students. Okay, and let us try to see the basic difference between physics and applied physics, because as per the information given, it is obvious possible that some of the students are just passed out their 12th, and some of the students are not aware about the nano. So I am going to spend few minutes on the basic fundamentals of these things. Okay, so if you see the difference between the physics and applied physics, okay, basically it comes under the major subject is physics, and it's a part is applied physics. Okay, so if you whenever we learn physics, okay, then the learner has a focus on understanding the fundamental laws of nature, right? And this is all we have gone through these laws, right? Newton's laws and gravitational law, right? But when we think about the applied physics, we are focusing our interest not on understanding, but how we can use these laws to solve the real world problems, right? How I can use this knowledge to for some kind of an day-to-day life application where the real people will get benefited out of it. So that comes under the area of applied physics. So basically you are using fundamental physics for application in real world, so which comes under the applied physics. Okay, so if if we consider the methods, then methods are more or less they are same. So for understanding of physics, whatever the method you use, either it will be theoretical knowledge or experimental knowledge, that you can use to understand basic fundamental laws of physics. And at the same time, the same two ways are useful to understand the applied physics, to use this knowledge of fundamental laws to use in some sort of an application in the applied physics. So in the sense that you have to just understand that what we are going to talk today is more likely towards the applied physics. Okay, I'm not going to tell you about the fundamental physics, but how applied physics can give you job opportunities in a future point prospects. So then the second word, as you can see, you have seen in my topic, is the nanoscience and nanotechnology. Okay, and as I said, maybe some of the students are not aware about the nanoscience and nanotechnology word. So let me start with the basic word, that what is nano. Okay, so nano is a Greek word basically, and its a meaning in Greek is called as a drop. Okay, but in English, if we transfer this, then it is called as a very, very small. Okay, or small, just a small. Okay, but you guys have listened this word when the Tata has launched its a car as a nano. Okay, it is shown in the corner of this slide, where you can see that the car was named as a nano. So can we call this as a really it is a nano? So we can say that it is a small car. The size of the car was smaller compared to the rest of the cars. So in that sense, they call it as a nano. But when we are looking at the scientific point of view, then obviously I will say that this car is not a nano. Okay, when we think about the scientific point of view, then this is not a nano car. Okay, so what is nano? Okay, because the word small doesn't represent how small it is. Okay, the word small doesn't represent how small it is, and how, in which region we can consider it as a nano. Now you can see that whenever we take some fundamental entity, okay, objects, then we have to measure it. And for measurement, we basically use the three terms, that is the what is the weight, what is the length, and what is the time. Okay, so if you take weight, then generally we measure the weight in kilogram, And as we are reducing the weight of the material, then you can see that when we are reducing the weight from kilogram, then we go to gram scale. Below gram scale, there is a microgram scale. Below microgram scale, there is a nanogram scale. And below nanogram, there is a picogram. So basically, we are here have already seen that even in the weight in the kilogram, there is a nano terminology, which is called as a nanogram. Okay, and its the unit is 1 nanogram is equal to 10 raised to minus 9 gram. Okay, similarly, when you are taking another parameter as a length, then we all are familiar with the scale meter. Okay, so you can imagine 1 meter, the length of 1 meter scale, right? And if we go down to the meter to centimeter scale, then 1 centimeter is 10 raised to minus 2 meter. Below centimeter, we can go to micrometer, and below micrometer, there is a nanometer. So here again, the nanometer is coming. So where the 1 nanometer is equivalent to 10 raised to minus 9 meter. Okay, and below nanometer, is there something, is the scale exist? Yes, so there is a picometer. Okay, so and below picometer again there is a femtometer. So likewise, when we are going down from bigger to smaller, okay, we have different ranges of units. Okay, and in a particular region, okay, we have this region which is called as an nano. Even in the time scale, we have nanosecond. Okay, we are able to measure it in nanosecond or picosecond. There are some instruments in the physics, when we analyze some lifetime of electrons and holes, then it comes in the range of nanoscale, nanosecond or picosecond. Okay, so what I wanted to tell you is that basically the nano is going to represent the smaller entity, but how smaller it is in terms of weight, it is 10 raised to minus time minus 9 10 raised to 9 times smaller than a gram. In when we take a length scale, then compared to 1 meter, it is 10 raised to 9 times smaller than compared to a meter, right? So likewise, you can understand when we are talking about the nano word, nanoscience or nanotechnology, we are dealing with the scale where it is very, very small. Okay, it is so small in the sense that in the sense that 1 nanometer is 10 raised to minus 9 meter scale in terms of scale, right? So that you have to keep in mind. And this is our just a uh, some sort of an scale I have tried to show here, where you can see that here 100 millimeter is given on your right hand side, and as we are going from right hand side to left hand side, we are decreasing the size of the materials. Okay, so these objects 100 millimeter, these are easily we can see by our naked eyes, right? It is easy that you can observe these objects in front of you. Okay, so 10 mm, 1 mm, but as you are going below 1 mm, okay, right, like below 10 micrometer, then our visibility to normalize is going down. Okay, we are not able to resolve these two lines, so our resolution power has get limited below 1 micrometer. Okay, so we need some special type of microscope which is called as scanning electron microscopes. Okay, so these microscopes helps us to identify the nanowort. Okay, so when we make some kind of a material in 100 nanometer or 10 nanometer, then we are able to then they get visible under these special microscopes, which is called as an electron microscope. Basically, I don't want to go in this era, but what just you all are familiar with the optical microscope, where you have used it in the your school days. And the optical microscope is basically increase your resolution up to few micrometer, but when you go below 1 micrometer, then the optical microscope again fail because of the wavelength of these photons which you are able to use for the imaging. Okay, so here the electron microscopes could basically help you to visualize at the nanoscale. So what the images what you are looking at here in the grayscale, these are all electron microscopes. Okay, and the scale bar is given here like this scale bar. This is 40 nanometer in range. So you can calculate the diameter of these dots, okay, which is called as a quantum dots. Okay, this is the left hand side. What you can see, this is a one dot, okay, having the diameter in the range of 5 to 10 nanometer, right? So these kind of things you can able to identify with this kind of microscopes. Now, as I said, that the thing, the nano word is not possible to look by our normal eyes, but we can experience it. Okay, I will give you this example where you can imagine that right now something is going on with you at the nanometer scale, but we are not aware about it because we don't have that ability power to understand that things are going on that scale. For example, if you take a human fingernail, then it is growing 1 nanometer every second. Okay, so you can imagine right now if you see to your fingernail, now it is growing with a rate of 1 nanometer per second, right? Likewise, the man's braid, it grows 5 nanometer every second. Okay, so things are going on right now with us, but we are not able to look at it because of these limitations with our ability. Okay, so that can be observed in these kind of special microscopes which I have discussed. Now, is it a new kind of an science and nobody knows it? Is it a recent science? No. Or the best guru of all of us is our nature. Okay, and nature has already created a lot of things which are beyond our syllabus. Okay, but when we get the strength of these microscopes like scanning electron microscopes, we realize that the nature is also full of this nano technology. Okay, so here I have given some of the examples of natural materials. Okay, natural materials are those materials which is prepared by nature. Okay, and if I prepare my own material, then it is an artificial material, right? Man-made material. Okay, so here natural materials, you can see fly's eye. If you take a fly and start to zoom its eye, then you can see that it has very nice pattern at the smaller scale. Okay, even this could act as an antenna. Okay, what you can see, a white line is there, it acts as an antenna, and diameter of this antenna is in the range of nanometer. Okay, even the second example is butterfly wing. You all have a familiar with the butterfly, you all like the colors of patterns on its feathers, but do you have you thought about what is the origin of these colors? This is not normal dye. Okay, this is a structure which is at the nanoscale, and basically there is a interference of light take place depending upon the structure of this nanostructure of these feathers. Okay, so if you see, if you take this feather and try to zoom it, then you can see that as you are magnifying the your magnification power and trying to see closer and closer to the surface of this butterfly wing, you will realize that it is made up of nanostructures. Okay, and the interaction of the light is play in such a way that you will get a interference and diffraction of that wavelength, so which will give you some kind of an for a particular color. Okay, so color, whenever you see the color of the butterfly wings, you have to think that this is an because of nano, and that is not an actual color which we paint in our house. Okay, so the third example is the gecko's feet. Okay, if you see the gecko's feet and try to zoom it out, again you will find the nanostructure. And the very common example is lotus leaf, where you can see that their water droplet immediately runs out. Whenever you put a water drop, it immediately runs out on it. And even if it is in the mud, the lotus is in mud, the leaf keeps themselves as a cleaner. Okay, so that is called as a self-cleaning process. Okay, so that is why it is happening, because if you understand and try to analyze the surface of these leaves, you would realize that there is a kind of a particular material which is very small. It has a particular structure, and it basically repels the water. It makes the surface hydrophobic. Okay, so again, as I said, I'm not going in the detail, but I think you have got an idea what scale and what science I'm talking about. So basically, here I would like to differentiate the two basic words, that is what is nanoscience and what is nanotechnology. See, again, as I said, there is a physics and applied physics. the similar concept is applied here, where basically whenever you study the nanoscience, basically you are studying the exact science behind this nano scale. Okay, why some effect is going on, why these things are happening there. So if you want to study the science, I mean science at that scale, then we have to separate it from normal science. Okay, why we have to separate it from normal science, that I will tell you in the next slide. But here what I wanted to tell you is that that is a science which is nothing but the study of those things at the nanoscale. Okay, and nanotechnology, we can consider that is a technology which is based on these nanomaterials, or the technology which is based on the devices which are at the nanoscale. So something which is at the nano, and I am using that nano in some sort of technology, some sort of day-to-day life application, then I have to call it as a nanotechnology. Okay, so you can see here that this is a study of matter at the nanoscale. Okay, and let me tell you one more important thing is that uh, if somebody asks you what is the nanoscale, okay, what is the reason in which we have to call something as a nanoscale, then you have to keep in mind that 1 nanometer to 100 nanometer. Okay, so this is the region, this is the era in which the whole nano world is occupied. Okay, and above this or below this, if you go below 1 nanometer, then obviously there is a, we enter in the atoms. Okay, and then the atomic physics is different. Okay, and then if you go below, then the nuclear physics is different. But we are interested in nano physics and nanotechnology, and the reason behind that is it has wonderful properties. Why this region 1 nanometer to 100 nanometer? Because the behavior of most of the material, they are sensitive to this region. Whenever the material goes below 100 nanometer, below certain nanometer, then its a behavior has got changed. Okay, and that's a fundamental science we have to understand under the nanoscience. And as I said, we if we use that kind of an, material for some sort of application, then it is called as a nanotechnology. Okay, and okay, so this is what the basic difference. Okay, again, let me tell you more about this. So okay, so as I said, why it is interesting, because when the material goes below certain nanometer, like a 100 nanometer region, then it's the entire properties like optical properties, structural properties, electrical properties, magnetic properties, mechanical properties, catalytic properties. So, you see, these all is the list of the properties of the material, and these properties get changed. Okay, they get entirely changed when we enter into the nanoscale. For example, okay, very quickly I will tell you. So this is a, all are well familiar, with the gold. Okay, if I ask what is the color of the gold, blindly you can tell it is a yellow, very shiny, lustrous yellow color. Okay, yeah, you are right, but when I take the same gold into the nanometer scale, like 100 nanometer, below 100 nanometer, or below 20 nanometer, can you see the color of these gold nanoparticles? Okay, now you can see that the yellow color of gold, which is our regular bulk material, our day-to-day life material, when it goes to the nano, it's the color become red, it's the color become pink. And depending upon the size and diameter of this gold nanoparticle, you have different types or different colors at the nanoscale. Okay, blue color, red color, pink color. Okay, so these kind of colors you will also get at the nanoscale if you change the size and shape of the size and shape of these nanoparticles. Okay, again, I would like to give you second example, like carbon. What is the color of carbon? Okay, even if you ask you a person who is not educated, and if you ask you what is the color of the carbon, he will immediately tell you that it is black. Yes, it is black. But when the same carbon goes to nano, and when we prepare the material like C60 or C70, what is this? It means when I take 16 atoms of carbon together and form a structure, then that structure is called as a full ring. Okay, then I call that the what is the molecular formula for that is C60, means 60 atoms of carbon. Then you can see the color of that solution is looks like this. Okay, but when I just add 10 more atoms to that C60 molecule, and when I change that material from C60 to C70, its entire optical properties has got changed. So you see how sensitive is the properties at the nanoscale, and that is the reason that why someone is interested, why someone has to study the materials at the nanoscale. Okay, these are the about the optical properties. I have given these two example. Let us take one more example about its mechanical property. So this is one more paper which is published in ACS Nano. So here you can see that they have shown that what is the application of carbon nanotubes. Now again here if you prepare the carbon in the form of a tube, right? Okay, in the form of a wire, then you can see that it has an extraordinary mechanical properties. For example, you can see here the weight of this LED is 46 gram. Okay, the weight of this LED is 46 gram, and it is not only lifted but suspended by two 24 micrometer thick CNT nanofibers. So you take CNT nanofibers and make a rope of 24 micrometer in diameter, and even that is not visible, very not visible to this here in the photo, but here is the place where you have basically used the carbon nanofibers. You can see the LED is not only, it is not only taking the weight of the LED, but it can also pass the electricity through it so that the LED can glow. Okay, so what is the science behind it? So as I said that um, when we see to our normal words, we are well familiar with the Newtonian mechanics and classical mechanics. But when we are not able to see the quantum mechanics, we are not able to, experience the quantum mechanics in our real world. But when you go to the nanoscale, then the real quantum mechanics comes into the picture, and there are certain, effects like surface area to volume ratio, quantum tunneling, quantum confinement effect, surface plasmon resonance. So these are the special, effects which have originated only at the nanoscale, and they are absent in our normal, bulk material, in our Newtonian mechanics. Okay, so that is the fascinating thing about the nanoscience and nanotechnology, because basically it involves the quantum mechanics in it, and the actual laws of quantum mechanics can be experienced at the nanoscale. Okay, so so if I ask someone that are you using the nanotechnology, then most of the people are not aware that they are everyone has kept the nanotechnology product in their pocket. Okay, that is nothing but the mobile phone. Your mobile phone and computers, or you all have a chip, okay, in it, and that chip contains basically millions of transistors. Okay, and if you see the graph, okay, then you can see the the length of the transistor lies in the 90 nanometer, and as the time is passing, okay, then the size of the transistor is going down and down. This is called as a Moore's law. Okay, where the Moore has already predicted that as the size of as the progress in the nanotechnology happen, the million chips in the fingernail has get converted into billion. Okay, billion on the same area. Okay, so just by reducing the size of the transistor, so now we have somewhere in the 10 nanometer, 7 nanometer. Okay, so that is mentioned. If you look carefully what is the processor, then they have mentioned that what is the nanometer length is used in that transistor. Okay, so not only in the nano electronics, but you can see the medical, in the medicine also, there is a use of nanotechnology, particularly in dentist. They use nano clay and so sort of nano materials for the treatment of teeth. Then you have a paint based on that. You have cosmetic materials, and these electronics. So there are certain technologies which are running, and these products you will find that it is going to increase and increase day by day. Okay, so who can study this course? Okay, now I'm assuming that there are right from 12 standard students are available. Okay, so I have those for those 12 standard students, I will say that this is the time that you can enter into the course like BSc. Okay, so you have to do the BSc, either in physics or chemistry or even in the nanoscience and nanotechnology if it is available. And then you can after completion of your BSc you can go for MSc. Okay, and if you want further, if you are more passionate about the research and research and technology about the nano science, then you have to go for PhD. Okay, so these are the degrees which offer you the knowledge about this nanoscience and nanotechnology, and it also give you an opportunity to work in the this domain. Okay, so here what you can see is the BSc is of 3 years, MSc is 2 years, PhD degree is 3 to 5 years. It depends on where you are doing and what situation you are doing. If you are doing full time, then it take less time. If you are doing part time, then it may take more time. And one more thing you have to understand is that whenever we are talking about the nanoscience and nanotechnology, we cannot make it for a particular subject, because if you see, then it is called as an interdisciplinary science. Now, what is the meaning of interdisciplinary science? Is nothing but the science which has contributed in all the other subjects. Okay, so there is a role of nano in chemistry, there is a role of nano in physics, there is a role of nano in biotechnology, engineering, material science, medicine, biotechnology, and surface science. So therefore, if this technology is going to help to all the sectors, then it is necessary for a student to gather the knowledge of all the subjects. And therefore, if you go for MSc or BSc and MSc, particularly in nanoscience and nanotechnology, you will realize that you have all sorts of subjects. Like in the syllabus, there is a subject of physics, chemistry, biology, mathematics, material science, environment, and electronics. Okay, so whenever some person is thinking about only engineering, he say biology is not important thing for me, right? Whenever some person is thinking about medical stream, he thought that okay, mathematics is not important for me. But no, here all the subjects are equally important because they are interconnected to each other, and in order to understand the nanoscience and nanotechnology, and that is the reason that even this technology is contributing in the medicine field. Okay, so there is a subject which is called as a nanomedicine. Okay, so and as I said, if you want to understand the science behind this, then of course the physics is going to help you, that why the things are changing at the nanoscale. Okay, so in that sense, okay, all these subjects are important. And now the thing is, what about the job? Okay, if I do this kind of an knowledge and kind of a degree, then what opportunities I may have in the future if I have a BSc in applied physics or MSc in applied physics, and or if I had done a BSc in applied physics and MSc in nanotechnology or MTech in nanotechnology. So these kind of things are we are going to discuss right now. So this is a conventional thinking, or I can say mistakes done by most of the students. The first is they choose a profession that parents like. Okay, so their parents have some ambitions, and they have some kind of an already pre-decided job for the student, and he just follow that profession. Okay, so that is a conventional thinking. Okay, what my father has did or what they are telling, I have to just follow. Okay, second is to follow what the offer others or friend do. Okay, so without any own research, my own research, what I will do is just what my friends are taking admission or what they are doing the job. Okay, let me go to that only. Okay, so this is a conventional, we see the students are doing around you. The inclination towards medical and engineering profession. Whenever student is goes to 11th and 12th, they have a in their mind only two streams. One is medical and an engineering, and if they don't get these two, then they think about the third one. Okay, so so there are a lot of opportunities. Okay, even I can contribute in medical by studying the applied physics and nanoscience and nanotechnology. Even I can contribute in the engineering by doing the same degree, right? I need not to be an engineer or a medical doctor in profession. Okay, if you have a passion regarding that subject, then you can somehow contribute to those subjects. Now look for a course which immediately offer high salary. This is very popular. Many of the parents come and just ask, okay, what after this? Can my son get 1 lakh after getting this degree? Okay, so this is the expectation. Okay, this is what the expectation after doing a, so this is a normal thing. Okay, being a core just for qualification. Okay, there are some students they don't know what to do. Okay, what I'm going to do, what is my goal or what I want to intend or what is my interest, what is my passion. Instead of this, they say, okay, let me complete BSc. Let me think whether I to go to MSc or some MBA or something else. Okay, so they are not defined. So they just take the admission and they think that, okay, let me get graduation, then post graduation, and then we'll decide. Okay, so that kind of thinking is always there. So in my opinion, okay, just to help the students, better that you have to think it before. Okay, so self assessment is very important. Self assessment means what? You have to, each and every student has to think about what is my passion. Okay, they have to assess their own personality. They have to assess their own, situation around them, what their situation allowing to do, and they have to analyze their things. What I like, what is my strength, what are my weaknesses. Okay, if I have that strength, then how in which profession this strength will be useful. I think that kind of self-assessment is important for the students. Second one is a knowledge of academic and related career options. Now the world is changing very rapidly, and this traditional way of thinking, an academic is now no more is going to help. So every year some new things are coming out. So you have to take out the knowledge, what the degree, what the syllabus is going to help for that particular career. Okay, and you can plan accordingly. Then the next is evaluation of occupational choices. Okay, you can evaluate how many so you have choice. Okay, either, okay, I can do these three things. Out of these three things, then or if you got three jobs, then you have a choice that which job is more suitable for me. Okay, so that you have to plan before. Then assessing the working conditions. Okay, so before doing you decide the profession, you just ask yourself, okay, there are 8 hours to work in this situation, can I work like that? So these are the think before doing that. Once you enter in that era and then you are thinking that, oh, I come somewhere wrong thing, then that is not going to help you. Choosing and managing your career, then a person and it has been seen that the person who is it is happiest when he chooses a job that he or she loves. What does it mean? This means that he's enjoying his own, suppose some person like teaching, okay, and some person like interacting with students. Then he is just enjoying this process. Okay, he don't have kind of a burden in his mind doing that profession. Okay, and that is the what each and every student has to basically understand for which job I am more suitable. If I do this job, can I enjoy? Okay, so money is most of the students I tell that don't think about money at the moment, because money will with some time your salary will get increased with the experience. Okay, that is not the problem. Okay, the problem is, are you enjoying the job? If you are enjoying the job, then you can run it for a longer time and you can give your 100% to that job. Okay? So that is more important. Now, while making a career choice, think about future goals at longer time scale. Yeah, that is again important. That most of the students, they thought that, okay, this let me do this MBA, try for this business, and if it works, then I will go for that. If it don't work, then I will don't go. So don't think like that. Think about longer time scale means, okay, after doing this, after 10 year, what is my goal? After 15 years, what will be my goal? For example, suppose if you are joining as a teacher, as an assistant professor, your goal should be, okay, after 8 years, I will be associate professor, or after next 5 years, I will be professor. Okay, so you have to have a make a plan about your career, and while choosing a career, you have to think not only 2 3 years, but you have to think for longer time. Okay, now, without wasting time, let me give you what are the opportunities for the students who have done, this kind of a degree. Then these are the list of your opportunities where you can see their government or private academic jobs are there, or government private research jobs are there. entrepreneurship is there. There are companies, okay, there are industrial sectors, forensic department and patent office. So that is what I'm going to highlight very quickly, because most of these are the jobs which are very familiar to you. So these are the positions in the academia. For example, if you are passionate about the teaching, you like teaching and interacting with the students, and you are very enjoying the teaching process, then you can join any of the government or private institutes where you have the positions like assistant professor, associate professor, and professor. Okay, the salary scale is in the range of 50 to 2 lakh and 2 lakh 50 thousand per month. Okay, it depends upon your experience and the position on which you have joined. Then the second kind of job is research. So wherever you see the research, then you can see that there are government institutes like CSIR, DRDO, TIFR, BARC, okay, JNCSR, IITs, ICER. So all these research institutes has a lot of funding. Okay, and there are positions which are coming out, which is called as a junior research fellow, senior research fellow, research associate, scientist. Okay, so if someone want to join junior research fellow, then the minimum qualification is MSc. If some student is qualified MSc physics or a MSc chemistry, okay, or MSc nanotechnology, then he can join on the as a junior research fellow. And when you complete 2 years of junior research fellow, then you get promoted for senior research fellow. Okay, and once you completed the PhD, then you are eligible for research associate or scientist position. Okay, and there are not only government, but there are now number of private institutes in the research are also increasing. It means all private universities has this kind of an opportunities are there, like Amity, Amity University, and SRM, and all other VIT. So these are well renewed private institutes where they have their funding for research. Then the Agarkar Research Institute, this Sardar Patel Renewable Energy Research Institute, and this is the research institute for sustainable energy. There is a boom for now batteries and kind of work. So everyone is rushing for developing the batteries. Okay, so for by looking these things, there are some people which are coming up and they are saying that let us set an institute where the only it is focused on the renewable energy. Okay, so they will only work on battery and supercapacitor and solar cells. Okay, so that kind of institutes are also available. Then you can see this is the list of government research fellowships to pursue PhD. Now this is in short of I could say that the this is a governments has taken initiative. Our central government has taken initiative where they are focusing on how we can increase the interest among the students, which that they should come for doing research at the doctor at the PhD level or even after PhD. So government is supporting a lot of fellowships. For example, Prime Minister Fellowship for Doctoral Research. So if somebody has completed MSc in physics or chemistry or any science discipline, he is eligible to apply this fellowship. Okay, and then he has to go through certain process. I will shortly explain what the process is. But these are the fellowships where all the MSc pass out students can apply. And if you get the fellowship, which is in the range of 25,000 to 80,000 per month, okay, and so these kind of fellowships are available to all of you. Once you get this kind of fellowship, you are eligible to do PhD. So the PhD, as I said, will take 3 to 5 years. So for that entire region, these fellowships are there. Okay, so what is the process for this? So let us see the quickly what is the process steps. Okay, first they will advertise to submit application. So what you can do is you can write the name of this fellowship and you can type it in Google or try to find out the website for them. And you have to find out where they give the advertisement. Okay, so once they give the advertisement, then you have to submit the application in that scheduled time. Okay, after you apply, then they will review and shortlist the applications, and then they select the applications informed for the interview. I mean, they review all the application, they shortlist it, and only inform for those applicants who are shortlisted for interview. And then the student or candidate has to go for the interview. When he clear the interview and if he got selected, then there is a list of awarded fellowships is given on the website. If your name is there, then an offer letter will also come to you, and you have to accept it, and you have to also tell that where I'm going to work by using this fellowship. Okay, so these are the governmental fellowships to do PhD. Okay, so if you don't want to do PhD, and suppose you directly want some job like scientific officer or technical officer, then very top institute is available around us in Mumbai, which is nothing but the Bhabha Atomic Research Center. So this BARC is basically promotes, okay, for the you know promotes for the vacancies which are at the scientific officer or technical officer level. So there are two ways to go in that. Okay, one is you have to complete their orientation course. Okay, so either you have to go for their orientation course for engineering graduate and science postgraduate. Okay, so if you have BE degree, then you are eligible. But if you are science discipline, then what you have to complete is MSc, okay, MSc in physics, chemistry, or any other science, nanotechnology. And then the second is either otherwise you have to go for DAE graduate fellowship scheme. So again, as I said, they again open the applicants, and then you have to go through this process. And if you got this fellowship, then also you get the enter in that. And basically you can see that because the BRC is working on this nuclear and atomic power plants, the more entry for the physics postgraduates are there. Okay, so this is the qualification. If you visit their website, then you will see that for physics discipline, candidate must have an MS in physics, applied physics with physics and mathematics at BSc. Okay, so these are the minimum qualification for an scientific officer post. Similarly, if you see DRDO, which is the biggest research and development center, belongs to defense organization. Here also you can see this is a very recent advertisement in 29th July 2022, where you can see 579 vacancies are there at the scientist B level. Okay, in DRDO, in DST. Okay, so these are different organizations where you have a lot of vacancies for scientist B. Now, what is qualification for them? As far as physics is concerned, you can see for physics in DRDO there are 10 posts was available, depending upon your caste and criteria. And then the essential qualification, if you see, at least first class master's degree in physics from a recognized university or equivalent, or if you have a valid gate score in physics. Okay, so that you have to be aware about that. These are the in these areas, if you have degree in these areas, then they are interested, you are eligible to apply for this. So here I have given a link for that. You can make a screenshot of this, and you can you can check this link where there are advertisements are coming, because these are defense and research organization recruitment and assessment center, RSC center of DRDO. So if there are any vacancies belongs to DRDO, then you can visit this website. Now, as I said, again, this is a government initiative, for the for the promoting research as who want to do as a career. Okay, so there are so many opportunities after PhD. Okay, so right from 27 year to at the age of 40 year, you are eligible for number of postdoctoral fellowship. Sorry. So what is postdoctoral research fellowship? If you have completed your PhD, and if you apply these kind of prestigious fellowships, and if you receive it, then you are going to work for that duration. And if you complete that duration, then it can be considered as your postdoctoral work. Means whatever work the research you have carried out after completion of your PhD. Okay, okay. So you can see that there are funding agencies like BRC. Okay, they have a KS Krishnan Research Associateship, 40,000 per month plus benefit like HRA, living expenses. They will offer you medical. facilities, okay, for by the BRC, and this is for 2 years. Likewise, NPDF, National Postdoctoral Fellowship, Nehru Science Postdoctoral Fellowship, CSR Research Set, Ramanujan Fellowship. This Ramanujan Fellowship, BSc Inspire faculty, these are very prestigious because these are offered for 5 years. Okay, if once you get selected, next 5 year, your salary will be provided by DST New Delhi. Okay, but with PhD, you have to prove an outstanding track record. Okay, and the salary is in the range of 1,35,000 per month. In addition to this salary, they also give you 7 lakh per annum as a research grant. Okay, by which you can use this 7 lakh to do your research, whatever the equipments, whatever the chemicals, whatever the facilities you want to develop, you can develop with this. So this 5 year means 35 lakh. 35 lakh is your research grant, and fellowship is in the range of 1 lakh 35,000 per month. This is for Ramanujan. Inspire faculty is more or like similar to that. There is a special, fellowship for women, which is called as an woman scientist. Okay, so those, you see the eligibility, how government has, do research in a depth, So those women who have completed their PhD, but they have a break in their career because of their, personal reasons. Okay, and if they have a break of 2 year or 3 year and they again want to come back to science, then those women are eligible for women scientists. You can see 55,000 plus HRA is given for per month for 3 years, and in addition to that 10 lakh per annum, total 30 lakh per 3 years is given for the research. Okay, so this is the recent SERB research scientist. Okay, you can see 1,25,000 per month, 7 lakh grant. This is for 2 years, and CSR research scientist pool scheme. Okay, so this is again 1 lakh, around 1 lakh. So this is again for 3 year and 40 year. So you can see up to your age of 40 years, government is supporting you to they are promoting you to do research. Of course, whenever you are doing this, kind of any kind of fellowship, you can simultaneously keep application for assistant professor or scientist position whenever you get the opportunities. Okay, there is no any kind of bound. You are not bounded to this fellowship. Okay, these are just given for you that too you can find your dream job. Okay? Okay, so apart from research and academics, you can also become an entrepreneurship. Suppose you are working in some laboratory and you come to know that okay, my project has come given me such an wonder material that I can work, I can make my own company. If you have that kind of an ambitions and that kind of an ability, then it is possible that you make your own company. Okay, for example, you see these log 9 materials. This is a IIT Roorkee based students based company who have started this company where they are basically commercializing application on graphene. Now this is graphene is again a carbon based material. Okay, I'm not going in that, but you can see, you just imagine that you have prepared a material, you have prepared a technique which is nowhere. Okay, this is your own research. This is your own you know kind of an innovation. Then you can use your innovation and make your own company. So that is called as an you can become entrepreneur. Okay, TerraCarb. Okay, TerraCarb is what they are developing is India's first zero waste technology platform for manufacturing graphene based admixture for concrete. Okay, so a lot of demand for concrete is there, and concrete is drastically creating a problem of CO2 generation, and therefore a lot of scientists are trying to find out a alternative for concrete, or how we can prepare the concrete so that the CO2 emission will go down. Okay, so these are the sort of the companies. Okay, so if you are more interested in this kind of entrepreneurship, then you can visit this link where there are lots of startups are coming up, where the peoples are where the students are basically using their own knowledge for their expertise of knowledge and for their jobs. And in industries also you can have a lot of opportunities. Okay, for example, energy sector, health sector, consumer sector, electronics. Okay, so there are now the you see our government policy is trying to initiate more number of more number of companies in India. Okay, they want that our import should minimize and we should export more and more electronic gadgets and things. So in that sense, the number on the number of jobs as a technician or as an engineer in R&D sector, this will increase in future, where you can apply your knowledge at lab operation or quality control or if, material analyst. Okay, so or you can also develop new materials and devices, okay, in that for that company. Okay, so that company also gives you some sort of and a good package for the R&D sector, R&D kind of a job. Okay, this is a forensic scientist. Okay, so this is again an additional opportunity you can think about, where this forensic scientist, you can work as a forensic scientist. I have given what is forensic science and forensic scientist, but you can see after if you are you have if you are HSC, I mean 10 plus 2 completed or diploma, or if you are graduate in any discipline, basic science, okay, then you are eligible. And what you have to do is you have to complete one certification course. So in addition, you see, if you are a graduate or postgraduate in any discipline, then you are able to get a professional certification. And if you just want certificate, then then HSC or diploma per graduation is enough. But for post graduation or graduation, you get a professional degree. And if you get that kind of degree, then there is a opportunity to work in government forensic laboratory or private forensic laboratory, or even some colleges or universities who teach the forensic science. There also you will get the opportunities. The last one is the patent agent. Okay, so if you are interested to work as a patent agent, then this what is basically this patent. See, if you are inventing something and if you get some invention, if you are research, if you are doing research for something and you get come to a particular result, where you come to know that okay, this is very, I have solved this problem, and now my product is becoming the cheapest material among the competitive devices in the market. Then better you go for patent. Okay, and when you go for patent, it means whatever you have invented, it gets protected by laws, the actual government laws. And for that you need help of patent agent. Okay, so there are patent agents which basically help you to protect your innovation. So you can see there is no age limit for this, but you have to qualify patent agent examination. Okay, and once you get this qualify this exam, then uh, you become a patent agent. And then once you become a patent agent, then you can have a different opportunities, like there are government or private institute or universities who appoint this patent agent for their university, for their laboratory, for their own research. So if somebody, like for National Chemical Laboratory, if you heard, okay, it is located in Pune. So this is an laboratory where they have their own patent agent. So if some scientist is have invented something, then he will not run out of the institute. They have their own patent office. So there also you get a job. National international companies are there who are doing R&D. Okay, as I said, the Tata. Now Tata has a big, Reliance and Tata. These big companies have their own R&D companies, own R&D sector. In their R&D sectors, also you have an opportunity as a patent agent. Then you can also work as a freelancer or entrepreneur, or you can become a consultation. You can just provide the services and take the charges. So these are the opportunities in India. I think most of the research related what I discussed at after masters or PhD and after PhD, all these opportunities, even in the companies, these all kind of opportunities are also available abroad. Okay, so don't stick to the India only. If you are getting an opportunity after completion of your degree somewhere abroad, then definitely you get a good quality amount of salary and life. So these are just with the help of my previous institute, School of Nanoscience and Nanotechnology, Shivaji University, Kolhapur. So I asked them to provide some of the slides, to share some slides just to motivate you guys, so that you will realize that these type of students are also enrolling different kind of jobs. So these are the placements and achievements of MSc who have completed in physics, applied physics, and nano science subject. So these are the, you see, this person is have done their own companies, okay, and the rest of the students have gone to some sort of fellowships like this Paris, University of Glasgow, and most of the universities in Korea. And this is a again another kind of a job which is called as an editor. So there are a lot of journals like Springer and Nature Communication, Nature and elsewhere. So these also need some kind of short of academic or scientist level people where they analyze the other people's work. Okay, so these are they are appointed as a scientific writer in Springer Nature. This is a company which is located in Pune, and many students have joined there. Okay, and these two students also got some fellowship after their MSc. So likewise, there are so many things have received by the students, and they are giving various awards and fellowships not only in India but abroad. And you can see these are the students like, as I said, in private university, they are working in private university like Mahindra Ecole Polytechnic Hyderabad, Pandit Deendayal Petroleum University, Gandhinagar, Gujarat. So don't keep that Jain University. Okay, so not only government but also private also have a lot of opportunities. Okay, so in conclusion, I will say that there are, so many things to do. But as I said, you have to choose the right one, which is suitable for you, which you like, which you are passionate about. Okay, and at the end, let me acknowledge Honorable Chancellor Sir, Dr. Asim Chauhan Sir, Dr. A.W. Santosh Kumar Sir, Honorable Vice Chancellor of Amity University, Dr. Shrikant Charati Sir, for and Dr. Sunil Dhaneshwar Sir for providing me an opportunity and for allowing us to conduct this webinar. And I would like to thank all the faculty members of Department of Physics. They are really, I'm grateful for them because they come to me and they insist me, they motivate me to make this presentation. And because of only them, I'm presenting to all of you. So this gives me a great pleasure to interact to all of you. So I am very thankful to all of the faculty members of Department of Physics, Amit University School of Applied Science. And I also would like to thank to the funding agency because I am working as a SERB research scientist and they are paying me. My salary is given by them. So let me thank to the SERB DST for the funding for providing funding and salary to work in the Amit University, Mumbai. Okay, not last but the least, the I would like to thank to all of the students, and I wish all the best. So thank you very much.
Thank you, sir. Thank you, Dr. Arif, sir, for your kind guidance. That was a really nice talk. It covered almost every field. So all the research opportunities that Arif sir has talked about are actually available or open for BSc and MSc physics, applied physics students, right? So he gave us a lot of information, but we also, using this information, you also need to search, go through the links that he provided, go to the institutes, Google the institutes, or Google the subjects or the different job opportunities that he has provided, and get additional information on it, of course. So yes, before I thank everyone, if there is any doubt, you can ask in the chat section. You can type your question in the chat section. Arif sir shall answer the questions.
Yeah, sure. So if any kind of question, please ask. Yeah, sure.
Yes, and our students are sitting in 305 also. If you have any questions, you can type, or let sir, Shanti sir or Darshan sir know. They can ask questions on your behalf. So yes, whatever. If you have any questions, we'll wait for like 1 or 2 minutes. If there are no questions, then we'll end the session. No, I guess that is it. So you don't have any questions.
Right.
So if you
either they are fully understood or they have not understood anything.
No, most of the our physics students are also there. So if you have any questions and you don't want to type or do not want to interact right now, you can just come down and talk to Arif sir.
Exactly. Yeah, that is what I wanted to tell. Yeah, if somebody wanted to directly come and ask something, then you're always welcome. Yeah, sure.
And discuss anything in details also regarding nanoscience and nanotech also, not just career opportunities, but if you have any doubt in that field also, you can always come down. He sits with us in the physics, in the staff room, SAT ASA staff room.
Correct.
So
correct.
yes, that is it. So thank you, Arif sir. And we also thank Sunil Dhaneshwar sir and Sarati sir for this opportunity. Thank you very much, Arif sir, for joining us today and guiding our students. Hope if they ask you questions, keep guiding them, keep guiding us.
Sure, sure, sure. Yes, yes.
So thank you. That was all.
Thank you.
Take care.
Thank you, ma'am. Thank you very much.